Hi everyone, we're now going to graph cosecant and secant functions, and these are going to give us up-U, down-U graphs. That sounds kind of mean. So remember that cosecant of x is the reciprocal of sine of x. And when we're graphing y equals cosecant of x, which is in red here, we're going to consider the corresponding guide graph, which is when you replace cosecant with sine, or later on, when you replace secant with cosine. The guide graph here, y equals sine of x, is in black, and that's going to help us a lot. You should always graph the guide graph, or maybe one or two cycles of the guide graph before you try to graph the cosecant or secant graph. Here's the graph of y equals sine of x, 2 cycles. From here, we're going to graph 2 cycles for y equals cosecant of x. By the way, because the period for sine of x is 2 pi, the period for cosecant of x will also be 2 pi. That's the same for cosine of x and secant of x. The period will be 2 pi for these 4 basic trig functions. Okay, now remember, cosecant of x and sine of x are a pair of reciprocal trig functions. So let's go back to tangent and cotangent, and let's talk about the relationships we saw there. Remember that, informally speaking, 0 and undefined are reciprocals of each other in basic trig. So for example, when tangent is 0, when we have an intercept over here, that corresponds to a VA for the cotangent graph. When tangent is undefined, and we have a VA for the tangent graph, that corresponds to an intercept, a 0, for the cotangent graph. So the zeros or intercepts for one graph correspond to the VAs for the other graph, where the other function is undefined. Well, we have the same relationship between this black guide graph for sine of x and this red graph for cosecant of x. Where do we draw the VAs, the vertical asymptotes, for y equals cosecant of x? Cosecant of x is undefined when sine of x is 0. That is, we draw the VAs, which are dashed lines here, through the x-intercepts of the black sine graph. X-intercept for sine, we get a VA for cosecant. X-intercept, or 0, for sine, we get a VA for cosecant. Intercept goes to VA, intercept goes to VA, intercept goes to VA. You draw VAs for the cosecant graph through the x-intercepts, or zeros, for the sine graph, the guide graph. Okay, now between these VAs, we graph these up-U shapes when the guide sine graph is above the x-axis, and we graph these down-U shapes when the sine guide graph is below the x-axis. And that makes sense, because remember, reciprocal functions have the same sign for the same value of x. Remember for tangent and cotangent. Remember for tangent and cotangent. Going back here. Tangent was positive when cotangent was positive, and tangent was negative when cotangent was negative. So for example, in quadrant 1, everyone's positive. Tangent is positive, and so is cotangent. In quadrant 2, tangent is negative, and so is cotangent. Positive to positive, negative to negative. So it makes sense that both the sine and the cosecant pieces will be either above the x-axis, like over here, or below the x-axis, like over here. Also, we get an up-U shape. First of all, it makes sense that since we have a symmetric sine lump between the two VAs here, that this piece for cosecant will also be symmetric about this line. Why do we have an up-U shape? Because when sine increases, its reciprocal function cosecant decreases. When sine decreases, its reciprocal function cosecant increases. They go in different directions. That was similar to what we saw with tangent and cotangent. Tangent had rising snakes, cotangent had falling snakes. So again, the features that we saw, the relationships between tangent and cotangent as reciprocal functions, we're also seeing here. The relationships between sine and cosecant. Again, when one is 0, the other is undefined. When sine is 0, cosecant is undefined. And since sine is never undefined for real values of x, cosecant is never 0. Notice that this graph for y equals cosecant of x does not have any x-intercepts. Cosecant of x is never 0. That's good to know. Cosecant of x and secant of x, by the way, are never 0. 0 is never in the range of these guys, the basic trig functions. Otherwise, the values have the same sign, positive to positive, negative to negative. If you look between the asymptotes and the intercepts, as one function increases, the other function decreases. That's why we have these up u, down u shapes for cosecant of x. They have the same period. It's 2 pi for both sine of x and cosecant of x, and also for cosine of x and secant of x. Now, what about these points where the graphs meet up? I'll put them in blue here. What about these intersection points between y equals sine of x and y equals cosecant of x? Well, that makes sense because, now over here, remember, cosecant is undefined when sine is 0. Now, what happens when sine is 1? Well, the reciprocal of 1 is 1, so cosecant of x is 1 exactly when sine of x is 1. Whenever the sine graph hits a y-coordinate of 1, the cosecant graph also hits a y-coordinate of 1. That's why the black graph and the red graph meet up at all these points on the sine graph where the y-coordinate is 1. Likewise, the reciprocal of -1 is -1. So cosecant of x is -1 exactly when sine of x is -1. So for every value of x where the sine value is -1, like here and here, cosecant of x, the reciprocal, will also be -1. So for this value of x and for this value of x, because sine of x is -1 here and here, cosecant of x is also -1 here and here. So that explains why the cosecant graph and the sine graph meet up at their max and min points. A max point for the sine graph corresponds to a min point for the cosecant graph. The period is the same for both. So, for example, we have one period between 0 and 2 pi radians. I'll erase the rest of these marks. We have one period between 0 and 2 pi radians. So on the sine wave, we get one cycle over here. A period is 2 pi radians. Now for cosecant, we pick up, I'll put this in orange, we pick up an up u and a down u, and we pick up a vertical asymptote right in the middle there, in addition to the two on the edges here. So a full cycle for y equals cosecant of x must consist of an up u and a down u, and you must indicate the nearby VAs in the vicinity of the up u and the down u. By the way, you could pick up half an up u, a down u, and half an up u, this sad face, that also counts as a cycle. But this here will count as our fundamental cycle, where we start with an up u here and then a down u here, because remember, our basic fundamental cycle for sine of x starts at the origin here. We're going from 0 to 2 pi. So our fundamental cycle for y equals cosecant of x will consist of this up u, this down u, and the three VAs in the vicinity at x equals 0, pi, and 2 pi. All right. So what about y equals secant of x. We basically do the exact same thing for its reciprocal guide graph, y equals cosine of x. Secant of x is the reciprocal of cosine of x. Secant of x is the reciprocal of cosine of x. Remember, cosine of x gives us an even function. The graph is symmetric about the y-axis. But notice here, this guide graph, y equals cosine of x, this is our guide graph. It's basically a horizontal translation of y equals sine of x. But cosine is even, so this graph is symmetric about the y-axis. Well, to get the graph of y equals secant of x, we use the same principles as before. We draw VAs through the x-intercepts of the cosine graph. Intercept for the cosine graph gives us a VA for the secant graph. Intercept to VA, intercept to VA, intercept to VA. And then we draw an up U, down U pattern. Up U when the cosine graph is above the x-axis, down U when the cosine graph is below the x-axis. So here, notice that we're getting one cycle here and one cycle here, but this time we get the sad faces I kind of mentioned before. Half an up U, a full down U, and half an up U. Actually, our fundamental cycle for y equals secant of x goes from 0 to 2 pi. We pick up this half of an up U, this down U, full down U, and this half of an up U over here. It's like a sad face. It's kind of weird looking, and also don't forget to put the VAs. It's kind of weird looking, it's almost like it's crying, but this does count as one cycle. This is the fundamental cycle for y equals secant of x. Again, we use the same basic principles as when we went from sine of x to cosecant of x. Like cosine of x, secant of x is an even function. The graph is symmetric about the y-axis. The period for all these will be 2 pi. All right. Next up, we're going to discuss vertical asymptotes, domain, and range. That's next time.